and a very warm welcome to everybody. This is a series of videos where EWM meets automation. This is the second part of the video where I deep dive into the MFS node of the warehouse monitor. My name is still Hendrik, and this series of videos is still created in collaboration with the EWM team at Swisslog, which is focusing on the integration between automated hardware and SAP EWM. For those of you who haven't watched the first part of this video about the EWM MFS monitor node, I would suggest to go back to the first video of the series, which I link here at the top of the video, where we look at the first nodes under the MFS node in the monitor. So we already checked the nodes communication channel up until handling unit. In this video, we will look at the nodes from handling unit move up until the telegram buffer. Going back one slide, just as a quick introduction, I promise you that within this video and the corresponding blog, you will get more technical details and more information than the SAP online and in-system documentation provides. I collected everything that I found which I thought would be helpful for you as a technical or functional consultant. And another thing that I would like to add up front here is that I expect some pre-knowledge in terms of EWM MFS. That means I will not explain all the objects, all the details about the objects, all the terms that are specifically used in EWM MFS. Again, here I do expect that you have some base knowledge. If you do not have this base knowledge, please check the video description. There are a couple of introduction videos as part of this series that you could have a look at in order to gain this base knowledge. Having said that, let us jump into the details with a one-by-one walk through the subnodes of the MFS monitor node. The first one of the second part, as I mentioned before, these nodes have been covered, so we will start with the handling unit move nodes, which basically shows the content of the HU move table, which holds the base for routing decisions in case conveyor environments, so in fast moving HU environments. And this has like rough destination bins for the routing in those environments. I will not go into details about the way of routing in such environments and how the case conveyor MFS routing concept looks like. I would like to push this into a separate video, which I will release sometime in the future, but that would go too far now. For the monitor video, I would like you to take away that this node basically shows the content of the HU move table with the rough destination bins for the HUs. EWM offers two methods here. The first one simply deletes entries from this table with the routing decisions, and the second one simply calls the SCWM add HU transaction in order to create warehouse task for one of the HUs, and it pre-fills the fields on the selection for the add HU so that you can create a task for the HU that you selected from this table. The next node shows the conveyor segment groups, and conveyor segment groups are basically a collection of conveyor segments which are maintained or controlled with this bracket as a group. It adds exceptions which had potentially be assigned to the segment groups. So in case the segment groups have an exception, you will see the exception also in the grid in the warehouse monitor. Now the only method that you have here is to set an exception, and that's pretty interesting. So whenever you set an exception for a conveyor segment group, EWM MFS will set the exceptions to all affected segments, so to all segments which are assigned to the group. And those segments which are having an exception will no longer be considered for routing decisions based on the LOSC. As the layout and rate storage control, for the records in the LOSC, you can add segments. If those segments then have an exception, then the LOSC will later not consider those records. And that's important to understand here. And setting an exception here will update table SCWM MFS CSGR, which holds the conveyor segment groups along with their customizing and the status in terms of having an exception or not. And subsequently, when you set the exception here, EWM calls the standard exception framework, where you can then trigger follow-up actions, like you know that also from other areas of SAP EWM. The next node is basically showing conveyor segments. So what I just explained for the previous node, we have segment groups collecting together separate segments, and those segments have again their own customizing and their own potential exceptions, which are then shown here on segment level. So basically this grid here shows the customizing along with like change timestamps plus potential exceptions here in this column. And how an exception is being processed and what an exception causes in terms of potential routing decisions, I already explained for the segment groups and in this context for the segments. The only difference here is that the exception is directly updated in table MFS CS, so we don't have the conveyor segment as a trigger here, but rather set the exception directly for the segment. But at the end, it's the same result. Yeah, the segment will have an exception, whether it's being set by the segment group or directly via the segment. Good, the next one is an important node, and I'm pretty sure that whenever you are using a, let's say, automated warehouse in any way, you will probably make use of the resource node, unless you are run like a pure horizontal conveyor or something like this. Usually you have resources as, for instance, cranes operating in ASRS. And those resources are created in transaction MFS_RSRC. And then you add resource types, which are created in the customizing. And in this node, EWM shows this customizing along with the last bin, which had been touched by the resource, and some change timestamps and potential exceptions. Now, the exceptions are shown here in these two columns. And the exceptions are also something that you can set via the methods that are offered here in this node. And the exceptions that you set here, again, in the same way as with the conveyor segments, trigger the standard exception code processing. Yeah, so you can trigger follow-up actions or some kind of alerts or workflows in the same way like exceptions can be processed in manual environments. And it is also possible to use this method here to remove exceptions. That means a resource which was set in error status before due to an exception can now be released again. And when you remove an exception, in this scenario, EWM calls the MFS WT-DET function module, which I explained also in the other video, which you can find here, where we looked at the communication from EWM to the PLC and the trigger, which is basically creating telegrams based on warehouse tasks. So if a resource becomes available again, that means it can receive a task again, and that also means that EWM would like to check in the given queue whether there is any task which can be handed over to the resource in form of a telegram. So this is happening when you release an exception from the resource here. The next method that we have is the recalculation of warehouse task. And in EWM, a resource does always have a specific capacity of task which it can process at a time. And this number of tasks which are currently being processed is stored in table SCWM RSRC. And this method here basically recalculates the number of tasks. So it checks the open tasks which are assigned to the resource already but not confirmed yet. So warehouse task in EWM with KZ SAP status X. So the telegram has been sent to the subsystem, to the resource, but has not been confirmed yet, plus those tasks or telegrams which are sitting in the outbound buffer, so in table MFS delay, but are not acknowledged yet. And this method calculates the sum and updates then the RSIC table. And the value is written here in the field MFS act tell. So that's the only thing which is being done by this method, and the actual number is actually also shown in the grid here. The third one is send status request, and with this method, then again, depending on the telegram types which are being used by your subsystem vendor, this method sends a specific telegram type to the subsystem, to the PLC which controls the given resource, and then expects a response. So it could look like this. Here you have the starting time at 57:35 seconds. We send a CRQ, which is a status request in this context, here from EWM to a crane, and then 10 seconds later we receive a status report here from the crane to EWM, which is a response. So this is the method which triggers the creation of the request, and everything else is then just a logical follow-up communication. Last one is the trigger of the telegram processing, which you see here. And this trigger is basically checking the queue which is assigned to the resource, and it checks whether within this queue there is a telegram or there is a task for which we can create a telegram and send it to the subsystem. Obviously, this method again then checks whether the resource as such has capacity at all to process a new task. So whether the max number of telegrams or tasks is being exceeded or not. And if the resource has capacity, and if there is a task which can be sent to the subsystem, then this trigger telegram processing will create a telegram for the given task. So this is the same thing which is also happening in case this background job is running, or any other processes in the context of EWM MFS triggers the check whether there are any tasks for which MFS can create a telegram and send it to the subsystem. There is no difference technically here in the back end of this method. Next one, last one, is the telegram buffer. So as I explained already in the basic video, where we talk about the communication from EWM to the PLC and the other way around, that all telegrams which are being received in EWM are at first physically stored in an incoming buffer, which is the table SCWM MFS telequeue. And in the same way, on the outbound side, the telegrams which are being sent to the subsystem are stored in a buffer table, which is called MFS delay in the outbound side. And the incoming telegrams are then being grabbed from this buffer table by the given report, and once it grabs the telegram from there, it sends an acknowledgement telegram to the subsystem. So the subsystem knows that EWM has received and processed the telegram. And in the same way, on the outbound side, EWM stores it in the outbound buffer table, waits for an acknowledgement telegram from the subsystem to be received, and once this acknowledgement telegram is being received, EWM removes it from the buffer table. And that's one of the purposes, but it is also required in order to buffer load in case EWM cannot process multiple telegrams at the same time. So at first they are stored in the buffer table and then processed from there sequentially based on the communication channel and number of processes which are available. What I wanted to show you here is that this subnode basically shows the content of the buffer table, which means the content of this telequeue table here. And along with the display of the records, it offers us 3 methods, and those methods can be used first to edit the telegrams. So we get a pop-up where we can modify the record which is waiting here in the MFS telequeue table. So we can modify the data before it is being processed. So maybe the telegram ran into an error and you want to modify something in order to process it successfully. Or we are in a testing phase of a project where we intentionally want to store and edit it there in order to test some different scenarios. And we can delete records from the incoming buffer table. So for example, if there is an error, the wrong telegram, wrong content, also usually during testing phase, might also happen in a live system, but we have the option to delete a telegram here from the buffer table and maybe resend from the PLC to EWM. Last option is process telegram. So that is something that should usually happen automatically based on our background jobs or multiple other different triggers like a task confirmation. But we can also manually trigger the processing here. But this will also just call MFS process a telequeue function module, which, as I said, is the same function module which is called from other triggers which are automatically being processed in the context of running MFS. So usually this method should not be needed, especially not in a production environment. The outgoing telegrams, as I said, are stored in MFS delay table. And in the same way here, we have a grid where the telegrams are being stored along with timestamps when they have been created. Plus, we have the same options here, so we can open a pop-up to edit the content of the telegram before it is being handed over to the subsystem. And we have the option to delete the telegram from the buffer table here. And the process telegram in this context here then calls CWM NFS Send function module, which is responsible to send telegrams to the subsystem. This is also the same which is being called in the context of these reoccurring automatic triggers in the context of other processes. We are done. We finished our walk through the MFS node in the warehouse monitor. I hope I could shed some lights on the functions, especially on the methods which can be used here. As promised, the blog post, which I added to the video description, has all the technical details. So for every node, for every method, you have function modules and methods and all this stuff which are being called in the back end. And you have the screenshots and the pictures of the coding also over there. So feel free to grab the data from there. In general, as a summary, you should keep in mind that the MFS node in the standard EWM warehouse monitor offers you access to customizing application and master data, so objects which are maintained in customizing as well as in the easy access via master data are here summarized. So the data is summarized and displayed in one view. So the monitor combines it into one grid. You have the option for monitoring, so transactional data like telegrams, HU movements and all this stuff. And you have the options to modify telegrams. That's what we saw on the last point here, either on the incoming or on the outgoing part. And we have the options to set exceptions to multiple different objects, being it conveyor, segment, group or segments, or also resources. And based on the exceptions, then trigger follow-up actions, and subsequently also the option to remove exceptions from objects. And this is probably the most commonly used feature in production environments, that in the context of troubleshooting, you either set exceptions here, or in the context of having solved some problems, to release and remove exceptions here to get your stuff going again. Having said that, I hope you like this video, could learn something. I would be very happy if you would subscribe to the channel so you receive updates for upcoming videos. And I would also be very happy in case you got in touch with Swisslog and the EWM team in case you have any queries or need any support for your EWM MFS project. I wish you happy learning in the future and hope to see you back here next time. Thanks and goodbye to everybody.